This video is going to talk about how to complete the square, but first of all, let's remind ourselves of what we mean by a perfect square when it comes to factoring. So let's look at this one, for example. We have a perfect square trinomial, right? So we notice that it's perfect square trinomial because we see that this number is perfect square, 16. It's the number 4 squared. And this number is twice as big as that 4, right? So in other words, we can factor this trinomial as x plus 4 quantity squared. If this doesn't seem right, remember that x plus 4 times itself would be x plus 4 times x plus 4. So you would have to distribute that and or FOIL is the acronym we use a lot, so to get that middle term. So the reason why we notice this observation that this number is twice as big as this one is because when we multiply the x times the 4 for the outers and the x plus 4 for the inners, we're going to get the 8x. Okay, so that's all should be review. Another thing I want to talk about before we talk about completing the square is just a visual way of looking at these trinomials using what are called algebra tiles. You don't have to really truly know what these things are in order to understand the visuals I'm going to show you in the next couple slides, but I just wanted to quickly recap or introduce these to you. So algebra tiles are a visual way of representing algebraic expressions. In particular, we're going to be looking at ones that have x squareds, x's, and units in them. So this square, this larger square, has a side length of x, and since it's a square, its area is x times x, or x squared. So every time we see an x squared, we're going to represent it with this large square. These rectangles have that same height x as the square, this big square does, but the width of them is just 1. So its area is x times 1, or just an area of x. So sometimes we'll see them vertically or sometimes we'll see them horizontally, but these are the same rectangle, just oriented differently. And then if we're using just numbers without x's, we'll be using the little squares that have an area of 1. Okay, so let's look at an example. We want to factor the same trinomial we just saw using algebra tiles. So we have x squared plus 8x plus 16. So I need to take one of these x squareds, right? I need 8 of the x's and 16 of these ones tiles, and I need to lay them in a way so that I can create a rectangle, or in this case, a square, because it's going to be a perfect square. So if I want to use 8 of these and try to keep it like a square, I'm going to put 4 of them over on this side. Now this isn't going to be perfect because I'm not lining them up perfectly, but I'm going to take 4 of my x's over here, and then my other 4, the other 4 I'm going to lay horizontally over here. Remember, what I'm trying to do is create a rectangle, or in these examples, actually a square. So you can use this to factor even when it's not a perfect square. Okay, and then the ones are going to be filling in. So I'm going to pause it for a second. Okay, that was a little tedious, but I've now created a square here. And if you look at what we have here, we have 1x squared, we have 8 x's, and we have 16 units. So we have our 1x squared, our 8 x's, and our 16 units. So I've put them all together to create a new square. Now, what are the dimensions of this big square? So we can see that the dimensions are, this length is x, plus we have each of these lengths are 1, so we've got 4 units long. So this length is x plus 4, and this length is also x plus 4. So the area of this square we've created is x plus 4 times x plus 4, or x plus 4 quantity squared. So again, we have the same factorization that we had over here, that x squared plus 8x plus 16 equals x plus 4 quantity squared, but we just have a visual representation for that. Okay, let's use this idea to do what's called completing the square. So we want to complete the square. What does that mean? Well, we're going to start with 2 terms. We have our x squared, and now we want 6 x's. So just like before, if I want to make this thing turn into a square, I better use half of them on one side and then the other half horizontally on the other side. So let me do that. So we see I have my x squared plus 3 of the x's over on this side and 3 of the x's over here. So what do I need to complete the square? So I literally want to look to see what do I have to fill in over here in order to complete the square. So I'm going to be able to fit how many of these little ones units over in this corner. So I'll have, let's see, 1, 2, and I'll have 3 across, right? That's going to be 3 this way, but also I'm going to be able to stack 3 vertically. So I'm going to be making a little square, a little 3 by 3 square. So I'm going to be able to fit 9 units down in this corner. All right, so what does it take to complete the square? Well, I've just added 9 to this binomial. So I've added 9 to this binomial. So I've completed this square. What square have I just completed? So what is the factored form of this square right here? Well, notice that this length is x plus 3, and this height is x plus 3. So I've just created a square that has area x plus 3 times x plus 3. So this square has area x plus 3 quantity squared. So we've completed the square. Now, I do want to acknowledge here that we have added 9 to this expression. So I'm not saying that the original binomial is equal to what we have. So when you go through the process of solving by completing the square, when you add a number to complete the square, you're going to have to keep your equation balanced and add that number to both sides of the equation. But I just wanted you to get the idea of what it means to complete the square here. That's what this video is about. Let's look at another example. Here we have x squared plus 2x, and we want to complete the square. So I'm going to take my 2x's, and rather than putting them next to each other, I'm putting one vertically and one horizontally because I want to complete this square. So what number am I going to need to add to complete this square? This is a small one. The only thing I'm going to fit here in this corner is just this little plus 1. So I add 1 to complete the square. And what perfect square did I just create? I just created the perfect square x plus 1 quantity squared. That's because this length is x and this length is 1. Okay, let's look at another example. Here we have x squared plus 10x. So it's getting a little bit tedious with the algebra tiles, but again, I just want you to be getting the idea here. So I'm going to go ahead and pause this and create the square. Okay, so this is the part we have, x squared plus 10x. And the question is, what do we need to add to complete the square? So I don't know that I actually want to add this with these tiny squares, but how many am I going to fit? I can fit 5 of these ones across this way and 5 of these ones down. So I'm going to be filling in this square with 25 units. And that's going to create a perfect square if I actually did fill it all in, right? We'd have this perfect square, and its dimensions would be x plus 5 times x plus 5, or x plus 5 by x plus 5 would be the dimensions. But so when we factor this, we'd get x plus 5 quantity squared. Now in this next example, we have x squared plus 5x. If we try to do this same process, we're going to see that we're going to run into problems because I can't split 5x's up evenly, right? It's not an even number. I could put 2 on one side and 2 on another side, but I still have this extra x I need to somehow account for. So this is where the visual model starts to break down, and we want to start to see what's the point of these last few slides? What's the pattern happening? So if I wanted to, I could put a little sliver of a half of an x on this side and a half of an x on this side, so just to get the idea. So what would I really be adding to this corner to complete the square? I'd be adding 2.5 by 2.5, right? So I'd really be adding, 2.5 squared, right? Or if we're thinking about this as fractions, I'm taking 2.5, you can write as 5 halves times 5 halves, and I'd be adding 5 halves squared. And when I complete that square, when I add this number, what perfect square does it become? It's just x plus 5 halves quantity squared, right? Because we'd have x plus that 2.5 or 5 halves times x plus 5 halves. Okay, so in general, how do we complete the square? We have our x squared plus some value x. What is it that we're adding always? Okay, so let's look at the pattern here. So when this number was 6, we added 9. When our b value was 2, we added 1. When our b value was 10, we added 25. So what is it that we're always doing to the b value? Well, we took that b value, we split it into 2 halves, right? So we cut it in half, and then we squared it. So to complete the square, we add b divided by 2 squared. And that becomes a perfect square. And the perfect square it becomes is x plus b over 2 quantity squared. Okay, so whenever you want to complete the square, you're going to be using this process where you're taking this middle term, the middle value, dividing it by 2 and squaring it. That's the number that you're going to be adding, and that makes it a perfect square. Now, again, you're going to see other videos where you learn how to solve using complete the square, and when you do that, when you add values to one side of the equation, of course, you'll have to add that same value to both sides of the equation. So this video is focusing on what is this idea of completing a square? Why are we calling it completing a square, right? We have a visual now for what this means. And in subsequent videos, you will learn how to use this process to solve